In the last video, we saw how we can use Foldl to replace a common recursion scheme. Now there is another fold function called Foldl, which replaces a different kind of recursion scheme. So let's have a look at the scheme we're talking about this time and see how Foldl works. So in this one, we've got the length of a list, which calls helper length 0 x's. Now we don't necessarily need these caller functions, we could just have helper length. It's up to yourself, this is just the way I prefer to do it. Now what helper length does is that each time it has an accumulator, a value that is carrying along, and it updates that at each stage by taking one element out of the list. So for length, it always has a count of the current length of the list, and every time we take an element out, it just adds one. Similarly for the product, it has an accumulator which starts at 1, and it just takes a value x out, times x by the accumulator, and then carries on to the next element of the list. So similarly for sum, it just keeps adding the value x to the total before it recurses on to the next value. Now this is a little bit different from Foldl. So what Foldl did was it was the common recursion where it replaced the cons by function all the way down to the base case, but it has to get to the base case before it can recurse all the way back up. What Foldl does is it starts at the first value, adds to the accumulator, and then moves on to the next one. So Foldl has to get all the way to the bottom to execute, which is not always the case, but generally it has to recurse all through the whole list. Whereas Foldl just goes one element at a time, updating. Of course, it still has to go to the through the whole list, but it just updates at every step. Whereas Foldl goes all the way to the bottom and then executes all at once. So let's see this in practice, and let's have a look at the type of Foldl. So Foldl has a similar type to Foldl, except from the accumulator goes first in this instance, so we get BA to B rather than A to B to B. And we have a similar list structure, and we return a B value. So it's not very different from Foldl in that instance. And in most cases, it will give you the same result. They do tend to execute to the same thing. There are cases where that's not true, and it's very important to understand when it's not the case. But let's have a look at replacing some of these with Foldl. Again, we'll do length list last because that's slightly more complicated. But if we want to take the product of a list, we can just use Foldl. We can give it the times, give it the value 1, and let's do 1 to 5. Now we got 120 for Foldl, and we got 120 for using the product of a list. So for Foldl, we should also get 120. And we do. So in this case, Foldl and Foldl are the same thing. And again, we can do this for the sum of a list. We got 15 out for this one, so if we do 0, and this is plus, then we get 15 out. So of course we can also do the length of a list, but this is where we have to give something a little bit more complicated. Now when we did this with Foldl, we said x and accumulator, but because those arguments are switched in this type definition, we had to say accumulator and x, and that goes to accumulator plus 1. So we hit enter and we get the length of the list 5. So far, this seems to be exactly the same as Foldl. There are some important differences, however. So generally, Foldl might give you the thing you expect. So I remember last week we used minus. We gave a value of 54 and 10 and 11. And as I remember, if I'm remembering correctly, we got 53 out from Foldl, which seemed a little bit strange because you would expect that this would just do minus 10 to get 44 and then minus 11, which should be 33. So if we hit enter, we do indeed get Foldl gives 33. However, when we did this with Foldl, we get 53 because of the different order of association. So Foldl can sometimes give you the more intuitive result. Often it does. Foldl sometimes does not give you the intuitive result. Now, there are other instances where Foldl is not what you want, and that's when you're dealing with infinite lists. So if I give Foldl an infinite list, it accumulates the value at every step, but it can never finish because eventually it would have to get to the end of the list in order to return a value, and that's not always the case with Foldl. So let's see that. So if I give Foldl the and let's say we give the value false, and repeat false. Now repeat just builds the infinite list with the value we give it. I'll show you that in a second. But if I hit enter here, nothing will happen, and eventually we'll get a stack overflow. I'm going to kill that before it kills my computer. However, and this is where it becomes a bit more interesting, if we give this to Foldl, we get false out immediately. And this is because when and is lazy in its second argument, it doesn't care about the other one. so it can just repeat. And we saw this with the short-circuiting of Boolean operators. So in some cases, when you're dealing with infinite lists, fold_r can give you a value out. Not every time, but sometimes it can. For example, if we replace this with plus, and give a value of 0, and we wanted it to sum the infinite list, fold_r is not going to have a better time here. So this will only work when you have a function that is lazy in its second argument. So sometimes you want to use fold_r. Generally, you probably would prefer to use fold_r because foldl can be less efficient. There is a more efficient version of foldl out there called foldl prime, I believe. I don't think it's in the preload though. That's something you would have to import to use. So in general, we might work with fold_r. Because that would give us the flexibility of sometimes being able to work with infinite lists. But it is important that you know both of these functions, and it's important that you know how they differ. Now remember, all that's different is the order of execution. Foldl accumulates as it goes, takes an element, applies a function to it, and updates the accumulator with that value. Fold_r just applies the function in the space where every cons would be. So it's the standard recursion that you would expect. Whereas foldl's a little bit different, it encompasses this sort of recursion scheme here. But either way, these are both useful functions to know. They're very good to understand. They're very powerful functions. We'll see more, we'll work with these more as we go through the class. But of course, if you have any questions about either of the folds, feel free to get in touch. Thanks.